Hello friends, welcome to Machine Learning, the future course. Welcome to part 3 classification. In the last part, we have seen the k nearest neighbor machine learning model, and now we'll start with SVM, which is also known as support vector machines. So let's look at SVM. So as you can see, this graph which consists of various points, and some of them are into red category and some of them are into green category. So as this is a supervised machine learning model, we are classifying based on previously known classes. So we already know that this set of points falls under category 1 and this set of points which falls under category 2, and now we need to define a decision boundary, as you can say, to just separate a region of graph which is into two parts, which is red region and green region. So there will be kind of a decision boundary which will actually separate this red region from the green region. So yes, when adding new points, these boundaries between this set of points will be very useful, which will be actually decisive in whether deciding whether this point is in the red region or the point is in the green region. So now let's look at this graph and predict which exactly is the line which will be the decision boundary for this graph. Will it be this one, will it be this one, or will it be this one? So what support vector machines does is it identifies a line which will have maximum margin when considered 2 points from each of those categories. So now consider this green point and consider this red point. Both these points are known as support vectors. So these 2 points contributes to the entire algorithm supporting this decision boundaries. So even if these points will be nullified, it doesn't matter, but this red point which is closer and this green point which is closer, these 2 points defines or contributes to the algorithm. So that's the support vector machine algorithm. Now what exactly is the classification, what exactly is the criteria to choose these 2 points? Why is these points chosen? And also the line drawing between these 2 points, the line which is drawn is known as maximum margin, and this margin should be maximum if you are choosing the points. So what exactly is the criteria for the support vector machine algorithm to choose these 2 points? Now let's look at a criteria wherein let's suppose these are set of apples which fall under a category of apple, and this will be a set of or category of oranges. Now what support vector machines will look for is that apple which is very much similar to an orange, and that orange which will be more likely than an apple. So apple and an orange, but it will be more likely to be on the other categories. So that will be the criteria for SVMs. I will again repeat my statement. And SVM, considering this is a category of apple and considering this is a category of orange, will look for that apple which is more similar to an orange, and hence it will be way away from this category or this group of categories. It will be away from them as it is less likely to be an apple, and that orange which is less likely to be an orange which will be more similar to an apple, so it will be away from this group of categories of oranges. So those 2 points are known as support vectors, and SVM will choose that point, will actually place their decision boundary, and the distance between those 2 points will be drawn, and that will be the maximum margin, and that is the criteria for SVM. And this line is known as positive hyperplane, the main line is known as maximum margin, and the lower line is known as the negative hyperplane. So SVM will look for an extreme case. So that is an extreme case where it will look for an apple which is more similar to an orange, and an orange which is more similar to an apple, and that will become the support vectors. So these extreme cases will be our support vectors, and once support vector is located, maximum margin line is located, and this maximum line will become our decision boundary for our SVM machine learning model. So that's it from our support vector machine model. We'll begin the actual machine learning in our next part using Python. So till next time, hope you are enjoying this video series. Thank you. Bye bye.